All right, next up we have Xu Zhang, who talks about smartwatches. She explored the smartwatch design space. Slides up, so please welcome our speaker. Thank you.
Good morning. I'm Cheng, here with my colleague Kent Lyons. We're from Yahoo Labs exploring wearable technologies. And today we're going to share some of the explorations with it, exploring the smartwatch design space. And we created some prototype we called Shimmering Smartwatches. So over the last 2 years, we have seen a bunch of smartwatches coming out to the market. And on the right, you can see Pebble, the first commercially successful smartwatches on the market. And then last year, Moto 360 came out. We're going to have the Apple Watch coming out soon this year. And if you look at all these watches, if you have one ever set up, you notice the first thing they will ask you to do is connect it to your phone. And then from this tested phone, the watches get all the smart notifications on them on your wrist through a 1-inch screen. And this is not how watches we're familiar with before these 2 years of explosion of smartwatches. What we used to have is this really simple design that does one thing or a few things really well. That's about time. And that has changed. So we look at the two extremes of the simple mechanical watches and the complicated smartwatches that's basically trying to squeeze a phone that has full functionality onto your wrist and say, maybe there's something in between that hasn't been explored, and we should go play with that. And so as a result, we created two of the examples. On the left here is a point. It has an analog watch face, but underneath the watch face, we have 4 hidden icons. And if you receive a notification from your phone, this will start to show. But if nothing is happening, it really just looks like a smartwatch. I mean, an analog watch. And then jumping a little bit. On the right, we have this watch we call Circle. And it has 12 LEDs that's laying in an array around your watch. And here we're showing 925 as the bigger, brighter dot shows you the hour. And then the smaller ticks show you the number of minutes that has passed in the hour. So that was the overlook of the two watches. The way we set them up is that the watch itself is really dumb. It has the LEDs and a Bluetooth low energy module in it that's controlling the LEDs. And the smartphone does all the thinking. It's basically the brain. And it talks to our watches with Bluetooth low energy protocol. Let's go into the details of the design here. So we pick a few notifications that you would usually expect on the wrist, including messages, phone calls, your calendar event, alarm, and something general, which would be your Twitter update or Facebook mention. And then with that, here's some example again. You get a text message and your watch starts going blink, blink. If you don't do anything to it, it'll turn into this glowing pattern showing you that you have one unread message. We map the color to the identification of people who send you the message. So when you start blinking in a different color, it shows that someone else has sent you that message. And similar to that, next slide. We designed the pattern for the LED for each single of the notification here. You can tell that it has a limitation on the functionality here. For instance, the general notification really is just a place for everything else that you have to sort of fit in. Otherwise, your watch will be full of icons, and that will probably be overwhelming. So taking this limitation and thinking about what we can do to give it more freedom and more display, we created Circle. Because we have now more variables to play with, actually we're able to design more notification on this one. And it was in the summer when the World Cup was happening, so we added sports. I'm going to show you that as an example of the variety of information you can fit onto a simple watch face like this. This is the current score of a soccer game. The green on the left is Team Green scoring 3, and orange on the right scoring 2, and they just go, and so we have a blimping pattern similar to when you get a new message and showing that the score has just updated. And here is the full explanation of how we design all the patterns. You really don't want to see the 5 minutes of video we have here, but they are in the paper and in the video, so you can check those out. One difference from the point watch is that we now have quantity to work with. So when you got 2 messages on a point, you will have 2 waves showing you that, and you sort of have to stare at it to count. And now that we have this spatial arrangement to show them all at the same time, we just like lit up more LEDs to show you that, and they give us some freedom in the design. One thing that's interesting about this design is that the spatial arrangement of the LEDs allow you to associate information with time. So with the activity level, for example, we will show for each of the hours how active you are, and then map them throughout your day. So when you look at them, you have this overall understanding of if you were sitting around during the morning and going for a little walk towards lunch, they're more active there, and this kind of difference throughout the day. So that was our 2 example of smartwatches we built. And you can see that for some prototype like Point, you have really specific icons, and you can show information on there, and by a glance, you know it's a phone call, it's a text message, and understand it right away. But then it has a limitation. Each single type of message would need a space on the watch face, and that gets really crowded. A more generic design, like the one on your right, the circle, you could possibly do more tricks with the mapping and show different kind of notifications. But then we have to really carefully design the patterns so that when you look at the temperatures throughout the day versus how active you are throughout the day, you have to pick very different color mappings so that users don't confuse the 2. And so that's some thinking through how specific or how generic you want the design to be. We also had this design trade-off between having information that's glanceable, so you look at your wrist, you understand that's a phone call that you need to address it right away, versus having more rich information that's all showing on the wrist. And here we look at a few of the information that we were trying to show on the watch, and you can basically categorize them into 2. On the left, you have incoming message or incoming call. They're really happening at the time, and you want to address them right away, and you want to be able to interpret that information quickly. And then there are information that's more just a state that is constant, like you have this many of unread messages, and you may take your time and interpret that and then go to your phone and address those. So when we designed the LED patterns, we thought about what variables do LED really afford. You can put it at a different location, light it up at different brightness level, or give it different colors. And you can also change the waveform of the lighting or vary it in a different temporal pattern. And so the ones that's glanceable and instant, we'll put them on the left, and the one that you actually have to look at for a little bit to understand, we'll put them on the right, so that we, when we were doing the mapping from the information to the lighting pattern, we try to make what is transient and happening to be mapped to some lighting pattern that you can look at and understand right away. And if it's lasting and less urgent, then you can take some time to read them through. So that is how we are mapping a variety of information onto a very limited display we have built with LEDs. And then the next, we're going to dive into how we made the watch themselves. This is what it looks like if you open the watch from the back. We have a Bluetooth low energy module built in the system, which is basically this one. The chip itself, the NRF51822, is actually 6 millimeter square, a lot smaller, but we chose this module that is completed with the antenna, so we don't have to worry about that. And then we built a custom board, the square one around it, that would allow power management, adding sensors, expanding the functionality of the bare system on chip. And with that BLE module, we add on top of that some LEDs, put a mask we print with a normal printer that would allow you to show icons instead of just plain LEDs. We took apart an analog watch and then stacked that into the system and then put them together into the point watch. And then for the circle, we have this NeoPixel ring that conveniently just have 12 LEDs in it, so we used that. And for each of the LED, we mapped it into 1 hour, and we put a little mask on it so that they don't blend into their neighbors. And then 3D printed the cover in white plastic, and again, put everything inside so it looks like your normal watch. So before I go to the summary here, I'm going to do a little advertisement for the Bluetooth low energy module we are using. On the left is the module we have from Nordic Semiconductor, and on the right is 80 mega 328, which is in Arduino Uno as the standard setup. You can tell that for each single measurement, the Bluetooth low energy chip is actually superior, but it does come with a proprietary soft device, the software stack, that would make it a little bit harder to use. So there's some extraordinary work being done in Red Bear Labs based in Shenzhen that they are porting Arduino, which is what everybody loves and has huge support for different hardware. They are working on porting the Arduino onto the chips so that you can just plug it in and program as Arduino. And so basically, if you don't want to use Arduino and feel like you're calling yourself as a knitter by buying a sweater and cut off the tags, you can switch to the BLE, and I promise it's really cool. And so in summary, we propose that instead of having a full 1-inch display on your wrist, you can have more limited LED display that you can still map all the smart notification onto it by leveraging the connection to your smartphone. And we built these 2 examples. They show the information we want, but they also have drawbacks. For instance, on the circle, if you are showing, say, your sports score, then you actually don't get to see the time. So the thing we thought that we're going to work on for the future is actually combine the point and the circle so that you have the LED around the watch, but then you also have an analog watch in the middle, so you have the time all the time. And that was our future work, except that later last year and earlier this year, the explosion of similar ideas coming out to the market that you can buy already, and I have one here. Instead of have a printed mask that's on the paper, this one has Swarovski crystals on them to diffuse the lights from the LED, and it shows your activity level around the clock. And that's pretty much being produced and given to everyday consumers and being tested in the market. So for instance, it's really great to see that the prediction comes true, but it's also pretty amazing to have your future work already done like in the market. And that will be the talk. Thank you for listening.
Questions, please. Yes, you were first.
Hi, it's Paul again from Queen's University. I really like the motivation you come from when doing this work. And I was curious, you were mainly talking about how to display information. I was wondering if you had thought at all about the input side of things and how you would like to see that happen in the future.
There are two ways you can show information there. One is by inquiring. So like the watch I have right now, you tap on it, and it will show you information, and it goes back to sleep. And the other one is actually inquiring it from the smartwatch, and then, smartphone, and have it mapped onto a watch. For our prototype, we didn't build any of this. We're focusing on output, but that's definitely something that would complete the whole design. Thank you. Hi, Eric.
Hi, Eric Pulse, mic not on, UC Berkeley. Is it on? Yes? Oh, okay, sorry. Really nice work. I wonder if you thought or had any reflections on, I know this was part of the design constraint, but if we loosen it for just a second, time and the way that we look at analog watches, the kind of, the design read is this is really temporal. And so I wonder if you would think about if you got a message showing how long the message had been waiting for you or how long something had been happening, or because you have this kind of nice, really easy kind of reference for people to understand. Did you think about that? I mean, I know kind of the constraints of your design didn't afford that, but if you could reflect on that.
Yeah, that's totally, like one example that I would totally appreciate that is their alarm clock going into snooze mode, and then I never know how long it's been snoozing, and that's actually information that's important. But the current design the current alarm design don't afford that. Maybe that's something we incorporate into like the alarm we have here to show you how urgent it is. So that's a great idea. Thank you.
Good, awesome. Thank you. Thanks for your questions. Thank our speaker again.